Sometimes you're going to be given a Cartesian equation, an equation that has x and y in it, and asked to parameterize that equation, or to take a curve and parameterize the curve. What you're being asked to do in that case is to write a pair of parametric equations that would generate the same graph. The simplest way to do that is to set x equal to t and set y equal to whatever the function f of t is. And then stop and think about what parameter interval is going to work to generate the part of the curve that you're specifically looking for. And in some cases, it may be more appropriate to set x equal to the function f of t and let y be the parameter interval. And again, you've got to think of let y be equal to t, the parameter. And again, you have to think about what interval is appropriate. So for an example, real quick, suppose we have the equation x is equal to y cubed minus 3y. And we want to graph the complete curve. Well, since I got a cubic function here, this is going to be an S-curve, but it's not solved for y, so it's not a function. It's basically going to be an S-curve that's kind of rotated 90 degrees to the right. So in this case, it makes sense for us to let x be t cubed minus 3t and let y be equal to t. And if we're talking about the entire complete curve, then we're talking about any value of t that's a real number. So negative infinity to positive infinity. Now what if we only wanted to think about the graph for values of y that were between -2 and +6? Well, you'd still have the same parametric equations. Your interval would just be different. This would be your parameter interval. -2 less than or equal to t less than or equal to 6. So I'm basically what I have to do there is I have to think about what values of t are going to generate y values between -2 and 6. And since y and t are equal, that's going to be exactly the same interval for t values. All right, here's a problem that's a little more involved, a little more complicated. I want to write parametric equations, and I'm going to have two sets of parametric equations that will generate a linear path. Whoops. Yeah, there we go. I want the linear path from the point P, which has coordinates -2, 3, to the point Q, which has coordinates 2, -3, and then to point R, which has coordinates 3, 5. Okay, now the way I would suggest thinking about this is the two sets of equations we've got to come up with. One set is going to give us a graph from P to Q. And then the second pair of equations is going to give us the graph from Q to R. Okay? So here's kind of how we're thinking about it. I'm going to use a parameter interval from 0 to 1 to get us the first part of this, the first leg of this path, and then I'm going to try to use a parameter interval from 1 to 2 to generate the second part of the graph. So here's how I'm thinking about this. When t is equal to 0, I need the x coordinate to be the point -2 and the y coordinate to be the point 3. Because when t is equal to 0, the object that's moving is going to be located at point P. So if I'm thinking about x sub 0 plus a times t, and y being equal to y sub 0 plus b times t. And I plug in 0 and negative 2 and 3. So x would equal negative 2 plus a times 0. Wait, sorry. I'm trying to find a value for x sub 0 is what I'm trying to do. So the x value is negative 2 and the y value is 3. And that gives you negative 2 for x sub 0 and positive 3 for y sub 0. So right now, at this point, we've got negative 3, nope, getting ahead of myself. The x equation is going to be negative 2 plus a times t. And the y equation is going to be 3 plus b times t. Next, I need to figure out a value for a and for b. Well, if I think back to the slope, think about the slope of this line. 3 minus 3 is 6. Negative 2 minus 2 is negative 4. And this is b, this is a. So here's what I'm going to try. I'm going to try x is equal to negative 2 plus 6t, and y is equal to 3 minus 4t on a parameter interval from 0 to 1. So I'm going to grab my calculator, which when I pull that up is going to cover that up. That's okay. Negative 2 plus 6t and 3 minus 4t. Oh, gosh, really having a hard time. Negative 2 plus 6t and 3 minus 4t on a parameter interval from 0 to 1. And I think a decimal viewing window will show me what I need. So hit trace. When t is equal to 0, we have the point negative 2, 3. And when t is equal to 1, we have the point 4, negative 1, which is not what we need. Alright, what we need is the point 2, 3. So let me think back. Let me try this a different way, because that didn't work. One thing you could try is just change the signs. Since our slope was a negative 6 fourths, you could put the negative with the 6 instead of the 4. But I'm gonna try it this way. I know that when t is equal to 1, we want the point 2, negative 3. So if I let x be 2, when t is 1, I can solve for a. Aha. So 4 is equal to a. And if y is negative 3 when t is 1, then I get negative 3 is equal to 3 plus b, negative 6 is equal to b. Aha. So my equations, negative 2 plus 4t and 3 minus 6t should work. So negative 2 plus 4t. I just made all kinds of mistakes when I tried that before. Negative 4 minus 6t. Now, calculate a value when x is 0. We have the point negative 2, 3, which is what we wanted. And calculate a value when t is 1. And we have the point 2, negative 3, which is what we wanted. Okay. So this pair of equations will generate the path from point P to point Q. Now we've got to go back and do the same kind of work to go from Q to R. So when t is equal to 1, I want the coordinates of my point to be 2, negative 3. So an x value of 2 and a t value of 1 gives me 2 equal x sub 0 plus a. Thinking about the y equation, a y value of negative 3 equals y sub 0 plus 1 times b. Alright, when t is equal to 2, I need the point 3, 5. So 3 equals x sub 0 plus 2a, and 5 equals y sub 0 plus 2b. Alright, so now what I've got is two equations in x sub 0 and a, and two equations in y sub 0 and b. So you're going to solve those systems of equations. So if you're looking at 2 equals x sub 0 plus a, and 3 equals x sub 0 plus 2a as one pair of equations that you're going to solve, and then negative 3 equals y sub 0 plus b, and 5 equals y sub 0 plus 2b as a second pair of equations. Solving those systems of equations, you should get a value of x sub 0 that's equal to 1, and a value of a that is equal to 1, and a value for y sub 0 that's equal to negative 11, and a value of b that's equal to 8. So the parametric equations, x equals 1 plus t, and y equals negative 11 plus 8t, on the parameter interval from 1 to 2, will generate the second leg of your graph. So we should check that. I'm going to turn off my, I'll just change the equations that are in here. 1 plus t and negative 11 plus 8t. This time we're going from a t minimum of 1 to a t maximum of 2. Okay, now that's not all fitting on the screen, but if I calculate the value when t is 1, I get the 0.2 negative 3. And if I calculate the value when t is 2, calculate value when t is 2, there we go, we got the 0.35, so we know that works.